Hello and welcome to another part of the random problem challenge. So we're going to have another medium problem here. Hopefully we get one that we didn't do before. Okay, and I think this is in Python. Okay, good. So we didn't do this before, so let's do this. Okay. So given an n by n grid containing only zeros and ones, so let's write this down. Given an n by n grid containing only 1 and 0, where 0 equals water, so this is pretty common. Water and 1 equals land. Find a water cell such that distance to nearest land cell is maximized, and return this distance. If no land or water exists in the grid, return -1. It's kind of weird. How I don't even know how that would happen. Yeah, so return -1 if no land or water. Maybe they're saying that there is no like water cell, is what I would assume. If there's no water cell, but it's all land or something, I think. The distance used is the Manhattan distance. The water between two cells is just x0 minus x1 plus y0 minus y1. Okay, so like if you had a cell like here and here, it would be, let's see. Okay, the x would be 2 and the y would be 1. Okay, so it'd be like 3. Sure. Okay, grid, explanation cell 1, 1 is this one right here, is as far as possible, because of the distance 2. Okay. And then here it is cell 2, 2. Yep. Okay, so let's think about how we would do this. So this seems like it might be a graph problem. Well, we already have a graph, right? Okay, I think I kind of get what we want to do. So I think what we want to do is, first of all, well, no, we don't need to do that. Yeah, I think what we want to do is we want to traverse through this grid and then just do a DFS from every single zero up until we hit a land or we're out of bounds. First of all, we do want to kind of check if there is a land cell. So let's just do that to start off. So let's just, because I think that'll be like an edge case, and we're gonna have to traverse through this anyway. So yeah, because we're never gonna find anything otherwise. So let's do that first, and let's just have some variables. So have directions as usual, like in all my videos, equals, and we're gonna have so 1 0 0 1 -1 0 0 -1. Okay, so we have the directions. Now we're going to want the rows and the columns. So we can just have rows technically, or yeah, rows equals length grid because it's an n by n. Okay, so now let's actually loop through this and make sure there is a land. Now, how would we want to do that exactly? Yeah, I mean, it's pretty straightforward, right? So you just have some check equals false, then for row in rows, for column in columns, if grid row column equals 1. Yeah, right? We want to check for land, so check equals true, and we can break here. Okay, and then we can just say if not check, so we never found any land, then I think we just return -1 here. There is no land anywhere. So I believe that would just be that. Okay, so now that we did that, we took care of like the no land. Now I think what we need to do is we need to do a DFS from every single row, or from every single or we could do a breadth first search actually. Maybe breadth first search is better. Yeah, I think we want to do a breadth first search actually from every single square. Yeah. Yeah, so I think we want to just loop through. Actually, oh, okay. No, I think I have a better way to do this. Yeah. I have a much better way. Okay, so instead of doing, okay, I have a better idea. So instead of doing a breadth first search from every single like 0, what we could do is we could do a breadth first search. This is kind of like a walls and gates, I think. Yeah, definitely. So what we're actually going to do is we're going to want to put the land cells in our breadth first search, and then we're going to want to go from there. So like if we have this example, we're going to put these 4 in there, and then we're going to go like 1 square from each of them, and that'll be the first iteration, and then 1 square from each of those, right? So in the first iteration, we're going to put in this, and this in there, and then we're going to put in this. Yeah, and we're just going to have some kind of like distance variable. Yeah, that sounds perfect. Okay. So it's actually, do we need directions? I think so. I think we still want directions. But now instead of this check, we're actually going to want, so for a BFS, we're going to want a deck, right? Standard BFS. And so we're going to put that in here. So deck, we need to call it something. So just call this, I don't know, lands or something. Equals deck. Okay, there we go. And then we just do lands dot append. And we're going to want to put it in the row and column. Perfect. Okay, now we just do if not lands return -1. Okay, so we didn't find any lands. Cool. So yeah, so we're going to have a deck. We're going to, so we can even write this down, deck of lands that we do BFS from until we hit every single location. Okay, and then what we're going to do in the zeros, how do we want to handle the zeros? So what we could actually do, let's think about this. We do need to like put some kind of numbers in here, but we also want to put in numbers that are different than these lands, right? Like we don't want to put a 1 here, for example. So what we could do is we can just change these lands to be equal to something else, right? So we can make them equal to some symbol. So let's just do that. So let's just say grid row column. Let's make it like -1 or something, right? So we're going to take all these ones, make them -1s. That way, actually, let's not even, yeah, sure. Let's just make a -1. It doesn't matter as long as it's a symbol that we don't use again. Okay, so we make all these lands -1s and we put them in our deck, and now we're just going to do a BFS from all of these until we go through our entire grid. Okay, perfect. Until our deck is empty, essentially. That means we don't have anything else. Okay. So here we're going to have res equals 1. Yeah, because the minimum distance from any land, like if it's an adjacent thing, it's going to be 1. Okay. Now what we need to do is we need to do while this is going to be lands. So while we do have like places to go to, then let's keep going. And otherwise we should have checked everything, I think. There might be some way where like you can't get to any land at all, but we're gonna, or there might be some way where we can't get to any, sorry, not land, any water. But I can't really see that off the top of my head so far, right? Like if there's lands and if there's lands and water, you should be able to get to the entire grid, I think. Yeah. Yeah, if you go in any direction. Okay, anyway. So what we need to do is we need to, while we have this, we need to do a for, I think like this. So this is going to be one iteration of the deck. This is going to be like one iteration of the breadth first search, meaning like if we have these 4, the first iteration will just take the 4 waters that are next to it. And we don't really care about this I value, so we're not going to use it, so we can just leave it like that. Now we need to we need to pop it, and then we need to try to go in every direction. Yeah. Okay. So let's just do row column here equals lands dot pop left. Okay, now we need to try to go into every single direction. So like, let's say we pop this, we need to try to go here, 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 here. So that's going to be for direction as usual, most of my VFS stuff. We'll just call that new row new column equals row plus direction 0, column plus direction 1. Okay, now we need to make sure that they are inbounds. So if zeros equal to new row and it's less than rows and zeros less than or equal to new column and it's less than rows again. Okay, so now we're inbounds. Now we also only want to put in things. So so the only new cells we want to put in are cells that are 0, and those are the only cells we want to update as well, right? So if we already visited something, we don't want to visit it again. And so what that's going to look like is we're going to change all these 0 numbers once we update them, and then we are going to so we're only going to want to put in 0. So this is and grid equals 0. We only care about new zeros. Okay. Now we want to update the value, and then we also want to put it into our deck to keep going, right? So in our first first we put in these ones, then in our first iteration we're going to put in these zeros because these are all one distance away, and then let's say we pop this 0, then we're going to put in this 0, and then when we try to pop all these, there's going to be nowhere else to go, right? Because the 0 will have a different value. Okay, anyway. So now what we need to do is we need to do grid new row. We need to update the value equals Oh, by the way, we can save ourselves a little bit of time here by having this. Do we want to res? I mean, yeah, whatever. We can use right, but we technically want some other it's fine. We could calculate it later. It's not gonna. We could do it here, but we could just loop through it again. It's fine. Okay, so grid new row new column equals, this is gonna be res, and then we're gonna want to put it into our deck. So that's gonna be lands.append. Okay, now if we are out of we're out of this loop, that means we went through like one whole iteration of the BFS, and now we want to update the res. Okay, now let's just print our grid here. Actually, let's not print our grid because it's not a good program. Like you might not get the chance to actually double check. So now what this should look like is it should look like this. So remember, we changed all the lands to -1s, so it should look like this. So it should be -1, then we have a 1, 1, and our second row is so we have 1, and then our middle one would be 2, 1. It should look like this if we did it right. -1, this should be a 1, this should be a -1. So it should look something like that. And then for our second example, it should look like -1. So this is going to be put in right away. This will be put in 2. Then we have 1, 2, 3. Yeah, and then 2, 3, 4. Something like that. I think that's what it should look like. So now all we have to do is literally just look for the max value. So now we can say res equals 0, and then we can just loop through the rows and the columns, and we can just take the max value. So let's do that. Let's comment this out. So this is just res equals max res grid row column. Now we do. Oh, okay. So I do see another case actually. Yeah. So this -1. Yeah. Yeah. Okay. So if not lands the other thing we need to check for is what if it's only lands? Then we don't have the water. So that's the other thing we need to check for that I forgot actually. So or length lands equals rows by rows, I think. So yeah, so if this is like a 1 by or whatever, if this is all ones, then land should be rows by rows, right? Because like if this is a 3 by 3, let's say, and it's all ones, then this lands will have 9 items. So we do need to check for that. So I guess this was like phrased badly, but really what they're saying is, yeah, if there is no land, like if they're all land or if they're all water, that's when you return -1. Okay, anyway, now we just return res, I think. So let's look through our code one more time, but it looks pretty good. But let's just see here. So we have directions, we have rows, we have the deck. So for rows and rows, for column and columns, if grid row column equals 1, append it to lands makes sense, and then we just update the value. Yep. Okay. If not lands, or yeah, so if there's no lands, or if it's all lands, yeah. Okay. All lands for, okay, row column equals lands.pop left. Yep. So we get a new direction here. Makes sense. Now, if new row is in a good index and it's 0, that's what we care about. Yep. Then grid new row column equals res. Yep. And then lands.append it. Okay, I think it looks good to me. And then we just get the max value. Yeah. Yeah. So technically, actually, I think would it work? No, yeah, it wouldn't work if it was all water. But yeah, sure. I think it looks good. Just kidding. I mean, as long as we have some slight like syntax stuff, that's not an issue. But hopefully, we don't have anything worse than that. All right. I only have rows. That's not good. So for this 0, okay, so it's saying our output is 0, and we're expected 2. Interesting, interesting. Let's print lands. Deck. Should be fine. Okay. So let's see what I screwed up. For I. Now let's see. Yeah, these are the right. I am curious. Okay. And I made res equals 0. Yeah, that should be fine. It is definitely interesting that it's returning 0, but let's just see. So row column equals lands.pop left. For directions, new row, new column equals, okay. If new row is, that's fine. Yeah, so this is just, yeah, that's fine. New column, it is an n by n, okay. And, okay. Yeah, so we're trying every single location, sure. Yeah. Okay. Kind of curious to, like, we should actually, let's do this. Let's print lands here just to see if we're updating correctly. Well, we should be, I think. Okay, so for some reason, I see what's going on, but it's interesting that that's the case. So it's actually saying that here, if we print it here, we're actually only going through this loop one time. So we're probably missing something really dumb. Definitely we're missing something dumb. For direction in directions, new row, new column equals row, yeah. If new row, okay, and grid, row column equals 0. And that should be equal to 0, right? So we have 1, 1, -1, -1. Yeah, it should be fine. Okay. Yeah, let's just see if we ever get to this. It looks like we're not, which is a bit weird. Yeah, we're not. Yeah, definitely strange. Okay. Let's print that. Should be getting in there for sure. Yeah, so like 1, 0, which is here, right? And that should be fine. So, oh, of course. Class expend a bunch of time. Okay, so that's not so bad. So it was a small mistake, but I'd be happy if that was it. And I think it should be. Cool. Okay, so our two mistakes were we forgot this range thing. Definitely could be cleaner code for sure. We forgot this range, and we had a column instead of rows, and we did have one wrong variable name, but our whole algorithm was correct. So I'm definitely happy about that. Okay, so let's think of the time and space complexity, and let's maybe draw, like, I don't think this can be improved. I mean, I can look at the editorial real quick. Breadth first search, literally the first thing they tell you. Okay, cool. So let's just think of the time and space complexity here, though. So time is going to be, so we are iterating through n by n already. I think we visit each cell once in this case. Yeah, so I think it's just n squared for breadth first search. And space, same thing, I think. Yeah, it's going to be around n squared, because if almost all of these were land, we would have that in our deck. Now let's just double check that in the editorial, but it should be yeah, n squared, n squared. Okay, cool. So we did have the optimal solution, which is nice. We did have a few errors, which definitely can be improved, but overall, I'm pretty happy with it. And it took us about 22 minutes, which is also, I think, fine. Okay, so hopefully you liked this problem, and if you did, please like and subscribe, and I'll see you in the next one.